Welcome guys, we're going to be solving this number logic challenge using modular arithmetics. And why should we use modular arithmetics and what is it about? And don't let us forget our domains that x and y must be integers. X and y are integers, therefore the range of value of x squared and 2 to the power of y is infinite. Therefore we use modular arithmetics, which is the congruence, to scale down those infinite possible values to just remainders of divisor 3, because we are going to be working with mod 3. Now for those that are not really familiar with the concept of modular arithmetics, it's just a way of representing numbers only in form of remainders. For example, x squared can be 49, can be 225, and so on and so forth, a lot of numbers. But the modular arithmetics mode 3 scales down those possible values to just 3 numbers, which can only be the remainders of the divisor 3, and the 3 numbers are just 0, 1, and 2. Now it means in this our congruence, 13 will be represented by, what remainder do we get when we divide 13 by 3? We get 1. Now for x squared, irrespective of whatever the values of x squared might be, we can either have 0, 1, or 2 as the remainders. But what are the allowed remainders in the domains of mode 3? So let's do a little bit of trick testing here. So that's for x squared. Now let's assume x is 0. If x is 0, it's going to give us 0, which is the remainder of 0. If x is 1, it will give us 1, which is the remainder of 1. If x is 2, it gives us 4, which gives us a remainder of 1, right? If x is 3, it gives us 9, which is the remainder of 0. Now you can keep on doing this for all numbers. We're going to realize that the only remainders you can get will be 0 or 1, and that's due to some algebraic reasons. And if you're interested in the reason, let me know in the comments. It means for x squared, the only range of values we can have are 0 and 1, right? And now what about 2 to the power of y? The possible values of 2 to the power of y we can have, that equals remainder of 1. When y is 1, we have 2 to the power of 1, which gives us 2. That's the remainder of 2. Then when y is 2, we get 2 to the power of 2, which is 4, gives us a remainder of 1. When y is 3, we get 2 to the power of 3, which gives us 8, which gives us a remainder of 2 also. Now you can keep on going for a long time. You find out that the only possible remainders we can have for 2 to the power of y is 1 and 2. And this also has an algebraic proof. In fact, there is a whole theorem on this. Therefore, since we have scaled out the range of values, now what we are left to do is to find the possible combinations of the two sides that can give us a remainder of 1 at the right hand side. And we'll see that the only possible combinations that we can have are 0 and 1. That will give us a congruence of 1 in mode, let's erase this, 3. Now to get our final answer, we just have to link our congruence to the equation. So now we'll come back to the right hand side. What are the values of x that gives us remainders of 0? And the values of x are when x equals 0. But when we look at our equation, x cannot be equal to 0. Because when x equals 0, we have 0 plus 2 to the power of no integer can give us 13. Therefore, 0 is wrong. That means the next value is when x equals 3. Therefore, x equals 3 is one possible solution. And guys, don't forget to subscribe, like, and comment so as to see more of my videos on number logic challenge. Now let's go to y. What are the values of y that gave us a remainder of 1? And those values are 0. And also y cannot be equals to 0, because if y equals 0, then we have x squared equals 13. 13 is not a perfect square, so that is not valid. Now we go to y equals 2. Therefore, y equals 2 is also a possible solution. Now let's test this solution pair. Now when x equals 3, we have 3 squared plus, and when y equals 2, we have 2 squared, and this gives us 3 raised to the power 2 is 9 plus 4, and that gives us 13. Therefore, x equals 3 and y equals 2 are valid solution pair. Please let us know in the comments if you have other solution pairs for us. Have a good day.